So now in this video we're going to look at using the NPN bipolar junction transistor as a switch, but I want to look at, higher voltages, maybe like 15 volts. A situation where that could happen is a 12 volt lithium iron phosphate battery. When you apply a charger, the charger can apply 14.6 volts. Once you remove the charger, the battery is going to go down to 13.6 volts. But if you have a circuit attached to that battery, you have the potential of 14.6 volts. So I have that applied to the circuit right now. Looks like we have approximately 14 milliamps of current flowing through the circuit right there. And we are lighting an LED, and it is in the on position right now. We can also, pull this, turn off a stray signal. We'll get it to glow a little bit right there. But yeah, we can turn it solidly off to the negative supply. That'll hold better, prevent stray signals. And then the positive supply. Again, to turn it on, we got a 10 kilo ohm resistor right there. And we could probably go lower in value on that as well, but or higher in value, I mean. But 10K is probably still okay. And we got the transistor. So the NPN bipolar junction transistor, I wrote earlier that this is an old diagram, that we can, do 200 milliamps of current maximum through the 2N3904, and that's what I'm using there. We got the emitter base collector. Emitter base collector when you're looking at the component, and that is the symbol. You can see collector base emitter on the symbol there. So yeah, we went up to 14.6 volts. So I did not want to use a 1000 ohm resistor, I'm pretty sure, because it would get pretty hot. If we got 14.6 volts as we do now, the LED is going to drop 2 volts. So that leaves 12.6 volts, in this case across the two resistors. But if we just had one resistor, that one resistor would have 12.6 volts just across it. But since we have two resistors there, they're actually going to divide up that voltage. And they're going to do so equally because they're equal value resistors. So now I got the multimeter. Since it's auto ranging, I just have to go to voltage. I don't have to move the red probe for anything other than high current, so I can leave the red probe where it is. But first we'll look at the supply voltage. It should be about 14.6, probably a speck lower right there. And there you can see 14.5. You lose a little bit of voltage in the wires and stuff. But yeah, we can check that voltage here as well. The transistor should be conducting. Pretty good. We should hardly see any voltage there. We will see a little bit. We turn it off, and we do have that diode, so it may not come to 14.6. The diode is blocking some voltage. But yeah, there we got 13.9. We come to the diode, and we should have, that full supply voltage. Remember, we're losing a little bit along the way due to resistance. So let's turn this on. So that was across the LED and the transistor. No current was flowing, so we know that there was no voltage across the resistors right there. You need a voltage difference. So yeah, no voltage across the resistor. So now we'll turn it on. We already looked at the other voltages, and we should have the supply voltage minus about 2 volts, and there you can see there. So it doesn't line up perfectly. But if I just go across one resistor, then we got half of that, so about 6.1. And we can do the math. 6.15 divided by 470 ohms. One of these resistors might be a little bit higher than the other because they are not perfect, and these two leads are close to each other. So we got 6.34 there. I think that was the slightly lower one. 6.34. No, that was the higher one. So this one probably has slightly higher resistance. That's one thing we can determine. But they're pretty close. And one way we can do that, I'll plug that LED, turn the power supply off just to be case. Just be careful. And we got ohm meter. So these two resistors now, they don't have a current path, plus the power supply is cut. But we can measure the resistance. I think this one will be a speck higher. 476 right there. And remember, it's expected that they're 1% higher or lower. So yeah, this one had a little bit more voltage across it. It has a little bit more resistance. that was expected. 461. I think this one, what was it, 466 or 476? So it's a bit higher is what we expected. So now I wired everything up and was surprised it wasn't working, and I'm recreating the scene, but I realized I had not turned the power supply on. The LED still wasn't lit, so I realized I put the LED in backwards. So those are easy things to do where a circuit won't work, even though technically everything appears to be wired properly. So now we got the long lead towards the more positive side of the supply, and the short lead, the cathode, to the more negative long lead anode. Got to put the LED in the right way or it will not light up. That's a common reason why it won't work. So now we got probably somewhere between 13-14 milliamps of current flowing through here. Like I said, I kind of want to simulate a lithium iron phosphate battery, a 12 volt one. You apply a charger, it can apply 14.6 volts up to that. You remove the charger and you got about 13.6 volts. So you can see LED is still lit right there. We could make a current source where the current will be pretty steady, but even as we change the supply voltage. But here we're going to keep it simple with the resistors, just how I would do that. And then you do like 12.6 volts. This is probably like a little less than fully charged when it is discharging. And then when it gets down to about 12, you kind of consider that completely discharged. You know, I think it's 20%. But in any case, there's not a lot of energy stored still. It's a good time to charge it. But you can go down to 10 volts if you're using a 12 volt lithium iron phosphate battery. This is low though. You don't want to go below this. You definitely want to recharge it as soon as you hit 10. You don't even want to sit there so that it drifts down over time. So, but still, you can see the LED is pretty well lit. We got about 9 milliamps of current right there. And we should be safe up to like 15. Although my lithium iron phosphate example, with the charger attached, about 14.6. So in any case, I'm trying to come up with, I'll just turn the power off now. And actually, I'm going to set this down to 5 volts because that's usually what I have set. So I want to make sure if I wire something else up, I don't put 15 volts especially across it. But in any case, I want to come up with a lot of schematics, put them on my website and stuff, where the circuits work at different voltages. So the challenge with this one was at this higher voltage with the single resistor. These are 1/4 watt resistors right there. And with the single one, that's 1,000 ohms, so it's twice the resistance. But if it's by itself, it'll have about the same amount of resistance as these two. With the single resistor, that's twice the resistance. It'll have all the voltage across it. It's going to get about twice as hot as what one of these is going to get. So these two are splitting up the heat because they are in series. They are dividing the voltage. Since, you know, the LED drops about 2 volts when the transistor's on, and the resistors, they take whatever voltage is left, but when there's multiple resistors in series, they divide it up based on their resistance. We saw that one was slightly higher, a bit higher, and so it actually had a little bit more of the voltage across it, but it was still close to like half because it wasn't that far in difference from that one. So, in any case, when you get to higher voltages, things get more complicated. So, hopefully this kind of helps show that. The transistor is can handle, you know, 625 milliwatts. That's its maximum, which is a lot more than 250 milliwatts, which is what the resistors are at. So, it's not as easy to overheat the transistor, but it can be done. And we're only dealing with like 14 milliamps of current. This can switch up to about 200 milliamps. That's maximum again. I try to stay about halfway from the maximum. And we can switch up to like 40 volts. So when it comes to the voltage we're working with here, 14.6, still not in an area where it's really pushing the limits of the transistor. But again, you know, I'd probably stick with like 20 volts or less. You know, I wouldn't try to push that either too much. But in any case, that's it. Make sure you check out the links down below and the other videos that are popped up on the screen. I will see you in the next video.